Bismillahirrahmanirrahim. Good day, everyone. Now we will discuss the delay circuit of pneumatic system in this video. I will solve two problems, and seeing that, I hope you will get a better understanding of the delay circuit. So first problem is sand is fed into a hopper from above. So we have sand here, and this is the hopper. When the hopper is full, when this is full, the operator presses the button and double acting cylinder slides open the door. So initially the door was closed. Okay. When operator pushes the button, the cylinder retracts this side. So the door will be open. This lets the sand fall into the wagon underneath. So when the door opens, sand will fall into this wagon and the amount of sand decreases gradually. The operator now presses the other push button, but other push button means this side's button. So the cylinder will extend. So, but there must be a short delay before the hopper door closes. Okay. To ensure that all the sand has emptied out, study the circuit. Okay, very good. So when the operator sees that sand level is very low, like sand level is here. Seeing that, the operator pushes the button, but there will be a 10-second delay. Why? Because this remaining sand has to fall into the wagon. So 10-second delay we are giving it. After 10 seconds, this hopper will be emptied out and all the sand grain has dropped into the wagon and door ultimately closes. So how can we achieve this? To achieve this, we need a delay circuit. Okay, let's study the delay circuit. Delay circuit has four classification. Let me show you all of that. Okay, this is a basic delay circuit. Suppose this is the first classification. I'm not telling you the name yet. First, let me explain this circuit. So when an operator gives a signal from this side, then flow will go first, checks this side, and it sees that this side is blocked because of the check valve. Then it moves through the throttle valve and the flow gets restricted. A few amount of flow gradually passes and fills this reservoir. So after a while, this reservoir gets full. When this reservoir is completely filled, then flow will actually go through here and actuate this 3 by 2 DCV. Then this side will actuate and we get a signal to the cylinder. So after giving the signal, there is a delay and this 3 by 2 direction control valve is normally closed because in the right side we can see a spring. It is the normal position of the valve and we can see the compressor is blocked. So the name of the circuit is normally closed. So on delay timer normally closed. Why on delay? Because I'm giving a signal, it actuating after a delay and the 3 by 2 direction control valve is normally closed in the initial position. Let's see the next classification. So in the next classification, there is a slight change in the 3 by 2 direction control valve. We can see that in the initial position, there is a signal. Okay. When the operator gives a signal from here, then after some time, this 3 by 2 direction control valve will actuate. So this is a on delay timer with normally open DCV. Here NO means normally open. Let's see the third classification. So in the third classification, the change is in the check valve. Okay, let's see how it works. So when operator gives a signal, then immediately it goes through here, through the check valve because this is open. Okay, so it immediately actuates the 3 by 2 direction control valve, and the valve was initially giving signal, and after getting a pilot signal, valve closes immediately. But another thing is happening behind. That is, this reservoir is actually filling on the behind. Okay, when the operator removes the signal from here, then because this reservoir is filled, it maintains a pilot signal here. So when the operator removes the signal, it doesn't immediately stops actuating the 3 by 2 direction control valve. After some time, this 3 by 2 direction control valve will stop actuate. So this is called the off delay, normally open. Let's see the last classification. So this is the last classification. From the picture, you can already guess that this is a off delay timer, but there is a change in the 3 by 2 direction control valve. So in the initial position, the 3 by 2 valve doesn't actuate. Because of that, this timer is called off delay, normally closed. So these are the four classification of the delay circuit. Delay circuits are mainly classified as on delay timer and off delay timer. And normally open and normally close is based on the construction of the 3 by 2 direction control valve. To better understand the delay circuit, I made an animation in the Blender software. Let me show you. This is the animation. Uh, Let me show and explain at the same time. So here you can see this is the throttle valve. We can adjust the throttle valve with this screw. This is the check valve, and you can see this is the 3 by 2 direction control valve. We have a pressure port. Pressure goes from here. We have a tank port and we have a cylinder port. Okay. Let me explain you this circuit and then you tell me which classification does this valve belongs. Okay. So flow goes from here. This flow is now pushing the 3 by 2 valve, but after it has been filled, then it will get pushed. See, the container is completely filled. This is the container part. If I didn't mention that, after filling the container, the flow pushes the spool inside the 3 by 2 direction control valve. See, the pressure port is now blocked. The cylinder port and tank port is connected. Now flow will go from cylinder port to tank port. Okay. Then when operators remove the signal, check valve opens and all the water gets drained from this check valve immediately. So immediately the spool returns to its initial position and valve doesn't actuate anymore. See? Then pressure port and cylinder port is connected again. So based on this, what kind of valve is this? First, we can see that there was a delay. So of course it's a on delay timer. And is it normally open or normally closed? So initially the pressure port was connected to the cylinder port. So it was normally open. The classification belongs to on delay, normally open. Okay, so now let's solve this problem. Here, in short, I will draw the circuit diagram. So, this is the double acting cylinder. To control this double acting cylinder, I need 5 by 2 DCV. To control this 5 by 2 DCV, I need two 3 by 2 DCV. Okay, so on closing, I need a delay. So this side will have the delay. Let's draw delay circuit. First, I need, here I just draw the 3 by 2 DCV slightly different. I hope you understand. Let's connect all of this. Okay, so this is the actual circuit. So now let's simulate this in the FluidSIM. I will go fast because I already showed you how the circuit is. And there are two delay circuit in this software. These are time delay valve normally closed and time delay valve normally open. I work with the normally closed type, so I am taking this. Okay, so this is the circuit. Now in the simulate part, oh, okay, so this is the circuit. Let's simulate this. First, let's set the restrictor to, let's say 15. Okay, when I push this button, it will immediately extends. Okay, works perfectly. When I push this button, the cylinder will close after a certain amount of time. See, when I push this button, immediately extends. When I push this, after a certain amount of time. So if I want to delay more, then I have to restrict more. Okay, let's see. Good. See, now the delay is more. So by restricting more fluid or making the reservoir size bigger, I can set the timer. Let's see the second problem. It says that Wonderful Worktops is a company that manufactures worktops for kitchen. The worktops are made from formica sheets glued into chipboard. A pneumatically controlled clamp holds down the glued sheet for 10 seconds before releasing it automatically. Okay, let's break this problem down. From the picture, I can deduce that this is a double acting cylinder, right? Okay, this rectangular shape object is the worktops. So what is worktops? When I first saw this problem, I didn't know what is worktops, so I googled it. So basically, these are worktops. The board above the kitchen is the worktops. Nothing fancy, nothing extreme. It's a very simple problem. These are simply worktops. So basically, worktops are made by gluing these formica sheets. So many sheets are glued together layer by layer and pressed with a cylinder or some heavy object. So exactly that thing is happening in our problem. So this is my double acting cylinder. This bar will push these sheets together, and I think this is a clamp or something which holds the bar in the middle position. So the if cylinder extends, the pressure is more, and when cylinder retracts, the pressure is less. So the problem states as control clamp holds down the glued sheet for 10 seconds before releasing it. So the circuit should be when I push the button, it immediately extends. Then after 10 seconds, it retracts. Obviously, we need a off delay timer, right? So I need to implement this circuit. And by the looks of it, I don't need a double acting cylinder. A single acting cylinder should do the work. First, let's draw the circuit. So this is my single acting cylinder, and to actuate this, I need a direction control valve, which is 3 by 2. And I will operate this direction control valve pneumatically. Now I need the delay circuit. It should be off delay. So the check valve is in this position. It is normally closed. And for the operator, I will give him a button. This 3 by 2 DCV is for the operator. Okay, let's break down this circuit. When operator pushes this button, okay, there will be a signal from this DCV and it will go here to this timer circuit, and from this path it will go directly to this 3 by 2 DCV. Okay, then this DCV will actuate and flow in this path and directly actuate this 3 by 2 DCV, and the cylinder immediately extends. And as the problem states, this will hold down the glued sheets. Another thing, behind the scene, this reservoir is filled. So after operator releases the button, then for this reservoir, there will be a signal present. For this signal, after 10 seconds, this 3 by 2 direction control valve will gain its initial position. Okay, actually I can do better, right? I can completely cut off this 3 by 2 direction control valve. Just join this line. So less 3 by 2 direction control valve is needed. Okay, let's search DCV delay. Okay, so we can see that there is no off delay timer. We should make one. So I will use this throttle check valve. Okay, and I need a reservoir. Now I need 3 by 2 DCV. Okay, this looks a little bit funny, but I assure you the logic is okay. Now I need the push button for the operator. So okay, let's simulate this. So this is the button for the operator. When he pushes the button, the cylinder should immediately extends. Okay, and here you can see the reservoir fills up almost instantly because the flow goes through the check valve. When the operator releases the button, then after 10 seconds or a time delay, this cylinder will gain its initial position. So let's release this. See, the reservoir maintain the pilot signal in this 3 by 2 direction control valve. And because of that, our cylinder was in extend position for longer time. So if we want more delay, then we just have to restrict the flow in this throttle valve. Extend, immediately extends, and after a long time, the cylinder will retract. Let's see. See? Okay. Now this looks like 10 seconds. So this was the answer of this problem. If you have any doubt, then please write in the comment. Thank you very much.